Welcome back, ladies and gentlemen. We are going to be taking a look at the graph on page 45, do some examples because we've finished the notes effectively. So here it is, a rough sketch of that graph. Obviously, you have a better copy in your booklet there, and we're going to go through it. So step one, cut up the graph. Always step one, cut up the graph. So for an area graph, we want to make sure we cut it up when it changes shape, changes sign, and crosses the axis. That last one, previously I said it wasn't super critical, but here's where it is critical. It's so critical, in fact, that's why I even mention it during slope graphs when I don't really need it. So for example, here, I'm going from a sloped line that's positive to a flat line. So those are clearly two different sections. This one here is, of course, a negative line. Normally, I would say you'd be able to go right from here to here. But for the purposes of calculating area, can't do it. We've also got to cut there. We also cut here, and there, and there. So in total, we're going to have 1, 2, 3, 4, 5, 6, 7. Lots of areas. Now, we're going to be finding the area under the curve. It's an area graph, right? We've done our cutting. Now we've got to find our numbers, and our numbers are going to be areas. So area under the curve, reminder, means the area between the line of the graph and the x-axis. So these are the areas that we are going to be finding. Down here, things get a little bit weird. This one's pretty normal. It's just a triangle. And even this one is just a really thin rectangle. But what do we do about this one? It doesn't go all the way to the axis. If it did, it'd be a triangle, it'd be simple, but it doesn't, which means that it makes what we call a trapezoid shape, which is this nightmarish looking square. Now, there's a couple ways to do this one. We'll get to it when we get to it, though, so give me a second. Let's get to going from 1 up to 6 first. So, number 1, we're looking at the area of a triangle. So, the area of a triangle in this case is going to be area of a triangle is going to equal to base times height divided by 2. That's going to be true for 1, 2, 4, and 5. In the case of 1, the base, the width across, is going to be about 3, I think. 1, 2, 3. Yeah, about 3. It's technically a little bit less, but this is about 3. So we're going to look at 3 times a height of -10 divided by 2. The negative is critical because that negative is what will make it so my area itself is a negative. We're going to get -15. Right? Because 3 times 10 is 30, divided by 2, 15. Okay, so that's the first one. We're going to do number 2. That one is the area of a square. Base times height. In this case, it's going to be from 5 to, I believe that's about 7. Let's take a look here. No, it's 9. So this is going to be 9 there. So that means the base is 9 times the height, which is me doing the wrong one. I'm not looking at a square yet. I'm looking at number 2. Come on, Mr. C, that's a triangle. There we go. So it's going to be from 3 to 5. So it's going to be 5, 2, times, in this case, +5. I was going to make it negative. Times +5 divided by 2. So that's going to give us +5. It's a pretty small area. Then we're going to go for 3. Now we've got the square. All right, so the area of a square, base times height. In this case, it's going to be 5 to 9, so it's going to be 4 times 5, and not divided by 2, so we get +20. Okay, number 4. Number 4 is another triangle. I'm not going to write the formula this time. You guys know it. We're going to get 1 times 5, +5, divided by 2. So we're going to get +2.5. And this is the last positive number we're going to get. Everything else here on is going to be negative. 5 is going to be 5 because it's 15 minus 10. times negative 34, all divided by 2. That one's going to be a little bit bigger, so quick calculation here just to make sure I get it right. We're going to get 85. Pretty big number. 6. 6 is going to be a square. It's 1 for the base times 34 for the height, so we're just going to get 34. And of course, all of these numbers now are negative. Negative 85, negative 34. Our last one, 7. Now here is where things get tricky. We've got two basic options on how we can do this one. We can work with the idea of a trapezoid directly, or we can work with a square and a triangle. So I could break this into sections like this and go, okay, I'll calculate the square, I'll calculate the triangle, and add them together. Totally works, very reasonable. Usually that's what I show to the grade 10s. They handle it no problem. You guys are welcome to do it too. But I'm going to show you guys another way to do this. This involves the formula for a trapezoid, because a trapezoid is just a shape, and every shape has a formula for its area. You happen to know squares and triangles, right? There's the square, there's the triangle. Well, the trapezoid has a formula too, and once you know it, you can do it. And the nice thing about the trapezoid formula in this context is that it's a lot faster. You don't have to do as much stuff. So this trapezoid formula is going to be height 1 plus height 2 divided by 2, all in brackets, times the base. In this case, the height 1 is 16, and height 2 is right here at negative 34. So I fill this in, and I'm going to get 34 negative plus negative 16, all divided by 2, and then I'm going to times it by, in this case, it seems to be about, what is that, 16? It's going to be 4 seconds. So I punch that in, and I'm going to get 34 plus 16 divided by 2 times 4. I'm going to get 66 negative. There you go, all in one-stop shop. Now, for those who are curious, the reason why this whole thing works is because the trapezoid formula, this part here especially, basically says, hey, you know what, I'm going to pretend that this trapezoid is actually a square right here in the middle. And I'm just going to pretend it's a square that comes across and goes up like this. But obviously there's a piece missing here. But conveniently, that missing piece exactly matches the piece that's sticking up out the top. It's just how the whole thing's set up. Anyway, we have now got our numbers. So we've done step 1, we've cut up the graph. We've done step 2, we've figured out all of the values. Step 3, at this point, is usually plot the graph. But there's an extra thing we have to do here. Remember from the notes yesterday. We can't plot these numbers. These numbers are displacement, and we don't plot displacement on a position graph. We plot position. It's in the name. So how do we do that? What do we have to do? Well, what we have to do is make ourselves a table. We've got time, we're going to have delta D, and we're going to have D. So at time equals 0, well, we'll leave that one for now. But at time equals 3, we found that the displacement was negative 15, which means we'll get that later. I want to fill this all in, and then we'll talk about it. So at time 5, we had a displacement of plus 5. At time 9, we had a displacement of plus 20. At time 10, we had a displacement of plus 2.5. Looks more like 2.6. At time 15, we had a displacement of negative 85. At time 16, we had negative 34. And the very last one at time 20, I just squeeze it in there, we got negative 66. So those are all the displacements that I got. Now, in order to do this question, we need to know where we started. As we discussed yesterday's video, if I start at an initial position of 0, then my final position at the end of moving 15 meters will be 15 meters, right? Like if I start here and I move to here, because I have a displacement of 15, that's where I end up. But if I started, say, here, slightly forward, and I move 15, then I will end up slightly more forward because I move 15 from where I was. Now, this particular question tells you in number 4, construct the appropriate DT graph assuming the initial position was 15 meters south, which means that my initial position, my displacement is 0, but my initial position is negative 15 meters. So after 3 seconds, I'm not at negative 15. I'm at negative 30 meters. Then I go up 5, so I go to negative 25 meters. Then I go up another 20, so I go to negative 5 meters. Then I go up another 2.5, so I get to negative 2.5 meters. Then I go 85, which means I get to negative 87.5 meters. Then I add another 34 on there. Oh boy, I don't want to make any mistakes. Well, any more mistakes than usual. 87.5, and I add 34. I get 121.5 meters. Then I add another 66, and I get negative 187.5 meters. That is an awful lot. And herein is the reason why we have to do this. If somebody wasn't keeping track and didn't add all the displacements to the initial position and just graphed this, their graph isn't going to be accurate. In reality, this thing is going a huge distance, negative 187 meters down. That's pretty far. It also makes sense. Look at the graph that we drew over there. The areas are so incredibly big below the axis. That area from 10 to 20 seconds is huge. That's going to have a big effect on everything. Whereas the areas above the axis from 3 to 10, they're tiny, so that's not going to have much of an effect. Now, obviously, if we didn't start at negative 15, we definitely would have gotten into the positive area there. But because we started lower down, we didn't make it. Okay, so we have now gotten our numbers. These are our numbers. We cut up the graph, we did the math, we got the numbers. Now we plot the numbers, and then we join the curves. Okay. Ruler. For this graph, we know that we're basically only going to be in the negative. So when we put down our axes and draw this, we don't have to put our x-axis in the middle, not by a long shot. I'm putting my x-axis at the top of the page because I'm not going positive the entire time. We're also going to need some really big numbers. We're going all the way down to negative 187. So I'm going to make this negative 200 down here. That's going to make this negative 100 in the middle, and this up here is going to be 0. Okay, it would make it 100 in the middle, except I didn't put it in the middle. Okay, there we go. Okay, then we got to go over here, and we got to adjust the times. Now the times are going to stay the same, right? So this is 5, 10, 15, 20. So now we just need to map out our various numbers. Now, okay, we probably need a little bit more gradation, a few more lines compared to just 100, 200. And we got negative 50 here. That would make this negative 25. This would be negative 75, negative 150. Oh, no, a little higher. Negative 125, negative 175. When it comes to making the axes, this is a way to do it that maybe you haven't seen before, where you just sort of take the two extremes and then you just cut it in half every time you need to put more details in. It can be useful, right? The other one that I often use is the 5, 10, 15, 20. You go up by 5s. Okay, so now we just need to plot the points. So we start at negative 15. So negative 15 is going to be like here-ish. Then we go to negative 30, which is going to be just a little bit under, and that's in the first 3 seconds, so about there-ish. Then we go up to negative 25 at 5. All right, that one's nice and easy. We've got a nice axis for that. Then at 9 seconds, so just a little bit earlier, we go all the way up to plus 5. So that's really close to the top, but not the closest we get. 10 we get the closest, right there. I'll say that's 2.5. Now, obviously, again, I don't have grids here, so my results are not going to be as accurate as you guys who have grids. Then, for 15 seconds, we go shooting all the way down to negative 87.5. So we're going to be like here or so. Then for 16, so 1 second over, we go down to 121. So that's going to be just slightly above 125. So about there, we'll say. A little lower, a little lower. And then the last one is 187, which is going to be at 20 seconds. And that's going to be somewhere about, let's say, there or so. Okay, we now have our plots pointed, and they're all over the place. Well, we have to connect these dots. That is the last step, right? We've done the cutting, we've done the math, we've done the plotting. Now we have to connect the dots. Now the thing here, as we've discussed, is that we connect the dots backwards. So the system, the pattern I said was curves become slopes, become flats, become zeros. But that pattern going forward like this was for slope, and we're not talking about slope anymore. We're talking about area. So we've got to go this way when we're talking about area. So the first one is a sloped line. A sloped line, when we're going backwards, turns into a curved line. But the question is, what type of curved line are we going to do? Well, we have to interpret the graph properly. The graph started off with some large velocity, 10, and it went towards 0. It is stopping. It is slowing down, which means the curve should be the kind that flattens out. Then we immediately pick up speed again, so we're going to sharpen. Up like so. Then it's flat. Well, a flat line when going backward turns into a sloped line. So I curve and I sharpen up to that point, and then I draw a sloped straight line to the next point. Oh, I missed. Let's just erase that and adjust. So like so. So the first two are curved like this. Then I straighten. Then I look at the next one. Oh, it's another sloped line. Well, a sloped line will go backwards to a curve, and again I'm going to 0, which means this one here is going to curve up to a flat. Now I'm exaggerating that in order to make sure you can see it, but yeah, we're getting quite the change, aren't we? To be fair, I think I put this point just a little bit too close. The lines aren't quite making sense. I think I needed to put it about there. So then this one goes like this, and this one here goes up like that. If only Mr. C had some kind of ruler that could do straight lines for him. I don't know. I guess he won't. Now we've got the big negative area. This is a slope. A slope becomes a curve. So now we've got to figure out what type of curve. And we notice we're going away from 0 to a big number. So this curve should be sharp. And that makes sense because if we can't really flatten, we're already at 0. So we go down like so and squeak the whole way. We then get another flat section. So we're going to straighten out. And then finally another curve section, and that curve section isn't quite at 0, but it's going towards 0. So it's going to be a curve that goes this way. It just hasn't gotten to the part where it actually flattens out yet, because it hasn't quite hit 0 yet. So there we go. There is our graph. A bit of a crazy one, isn't it? Like, before, we would always get numbers that got smaller, right? We would have calculated something and gotten a smaller number, and our graph would have had to sort of like cut off the ends. Now we get a bigger number. It's just kind of the nature of working backwards. But notice the different things we had to do. Cut the graph up. That was pretty straightforward. Do the math. This math down here should be pretty straightforward. Remember to add. That part people usually miss. Then plot the points, and finally connect the dots. The basic steps are the same. Cut, math, plot, draw. But there are just enough extra steps like calculate area, add displacements, cut when you cross the axis, draw, make sure you go backwards in the order. There's just enough little changes to make this easy to get confused. So that is why we're going to have so much practice. Obviously, I'm going to be putting a few more videos up together to give you guys practice or some answers for the next couple pages. But for right now, we'll leave it there for this video. Feel free to try the questions on 46, 47, and from 48 on, you will discover that there is an awful lot of practice. Do what you guys can, and I will see you guys next time. Quick correction, I just noticed I ended up plugging that into the calculator wrong. The answer shouldn't be 66 there, it should be 100. That doesn't really change what we end up doing, but it does change the final result. So my apologies, ladies and gentlemen. This should be 100, which means that this should be 100, which means that this should be slightly different. We should get negative 100 here, which means we should get 221.5, which means that this final dot should be even lower. So it basically would be off of my current graph, and it would still have the same connection. It doesn't really change much about what's happening, but it does demonstrate the importance of using your brackets properly. I forgot to put the brackets in, so when I did it on the calculator real quick, it did 16 divided by 2 to make 8, added that to 34 when I wanted it to do the whole thing. So, oops. On the plus side, that correction, easy enough to do. Hopefully the rest of it made pretty good sense and you guys see everything, and I'm sure the clever person who catches my error will be able to send me a comment. Anyway, see you next time, ladies and gentlemen.